Welcome back, Physical Science 20. This is the 11.2 booklet, Mass and the Mole. And it pertains to pages 313 to 319 of the textbook. And what we're looking at here is determining the molar mass of a substance, relate the mass of an atom to the mass of a mole of atoms, calculate the number of moles in a given mass of an element and the mass of a given number of moles. Calculate the number of moles of an element when given the number of atoms, and calculate the number of atoms of an element when given moles. So first of all, if you look at what is referred to as atomic masses, those masses that you see on the periodic table, they're based on the carbon atom. And if you notice, hydrogen, the lightest element, has a mass of approximately equal to 1. And that makes sense, because if you had a bunch of substances and you'd likely assign the lightest one a value of 1, then relate everything in terms of that. So that's kind of how it's done. Now the lightest atomic mass, of course, is considered to be 1/12 the size of a carbon atom, because the carbon atom is given a value of 12. Why are atomic masses not whole numbers? Because there's different versions of each element called isotopes, and those masses that you see in the periodic table are an average of all of those different versions or isotopes of an element. Therefore, the molar mass is the mass in grams if you had 1 mole of that substance. So not 1 atom, not 3 atoms, but 6.02 times 10 to the 23rd atoms. That would be referred to as the molar mass. And it just so happens that when you take 6.02 times 10 to the 23rd of a particular atom, that mass is equal to the number that you see in the periodic table. So for example, carbon is 12.0. Its relative mass is 12.0. If you were to take a mole of carbon atoms, it would be 12.0 grams. So those numbers are equivalent to what they would be in grams. So here I mentioned that. How many carbon atoms would have a mass of 12 grams? So if we look at that, 1 mole is 6.02 times 10 to the 23rd particles, and the big thing there is that is equal to the atomic mass in grams. So if you look at the periodic table, as I mentioned, and if you have a mole of substance, that number, you can slap a grams onto it, because that is what it would be. So this many carbon atoms would have a mass of 12.011 grams, as stated on the periodic table. So that's the neat thing about the mole. If you take the mole of anything, that number that you see in the periodic table represents the mass of it. Atomic mass unit, AMU, and molar mass. So the units are different. The atomic mass unit is the relative mass, like I was saying. Hydrogen being the lightest value of 1, carbon being 12, just relating to each other, whereas molar mass represents grams. Same number, but different unit. Okay, and then we have quite a few questions here that we could use. So simply converting from moles to grams. But before I'm going to do that, I'm going to show you this Y chart, which I think you had on the previous assignment. So all the conversions, and of course this chart is in the shape of a Y. So far in 11.1 we dealt with this, going from moles to particles and particles to moles, and those particles, depending upon what they are, it can be atoms, molecules, or formula units. There's also a conversion off there that we'll look at later, going to atoms or ions, vice versa, as well as over here we may do this conversion too. But using moles to go to mass or vice versa, we're using the molar mass. So when going from moles to mass, you multiply the mass in grams over 1 mole, because moles need to cancel. Or if we're going from mass to moles, you multiply by 1 mole over the mass in grams. And then of course what we haven't looked at yet was volume conversions. So you may want to pause the video just to get this down if you didn't get to do that so yet. So if we look back over here, all of these, so we're going from moles to grams and then from grams to moles. I just pulled this from page 315 of the textbook, questions 11 to 12. So from going from moles to grams, if you look back at the chart, moles to grams, we need to find the molar mass of the substance, and that many grams over 1 mole will be our conversion factor. So when we look up aluminum, silicon, cobalt, or zinc, you just simply look up those masses on the periodic table. If you look at the periodic table, aluminum is 27.0, silicon 28.1, and I just go to 1 decimal place with all of these. Cobalt 58.9, and then zinc 154 65.4 grams. And if you look at that, of course the molar mass represents grams per mole, so moles cancel and I'm left with grams. So 96.4, 1197.0, but I went to 3 sig figs, 1, 2, 3, 7 bumps this up by 1, so technically it's 1200 with this 0 being significant, or write it in scientific notation. Over here 203, over here 160 I get, but I need to have 3 sig figs, so I put a decimal after that to include the 0 as a significant digit, or put a line over top. Okay? Now vice versa, going from grams to moles, so grams to moles, I'm going to divide by the mass in grams. So looking up all those masses, silver 107.9, so you multiply by 1 mole over 107.9 grams, grams cancel, and I'm left with moles, 0.236. Sulfur, 32.1 grams. Zinc, let me just get rid of that. Zinc, 65.4 grams. And then iron, 1.00 times 10 to the 3 is just simply 1,000. 3 significant digits though, because it's in this form. Iron is 55.9 on the periodic table, so we get 17.9. So you can see it's very similar to what we did before, except using a different part of the conversion table. Okay, and I had that slid in there. Calculate the mass of the following. So here I threw a few other examples in. See if you can do these. We're almost at the end of this video, so I'll leave you with A and B here. See if you can make those conversions, and then check out with part 2 of this 11.2 booklet to see how you made out. Okay, see you shortly.